Hello, my dear students. It's me, Dr.Prajna Mattihalli, working in Government First Grade College, Dharwad, Karnataka. Let me explain today what are the location models while deciding the plant location. In my earlier video, I have explained theoretical part of it. That means what is plant location and what are the steps involved in decision making of plant location and how we are going to decide about it. For example, as a first step, we have to decide in which nation the plant has to be located. Then comes the decision of the region. And as a third point, we have to decide in which locality we have to locate our plant. And as a fourth step, we have to decide the exact site. Even we have discussed the factors which will be there in every step. After deciding and after choosing our exact site, we can do the work successfully. Now, in this decision process, there are some mathematical models to decide about the location. What are those models? First one is factor rating method, and then point rating method, and break-even analysis, and finally qualitative factor analysis. Let us go into the deeper part of it. Let us understand one after the other. As a first method, it is factor rating method. It involves giving rating to each factor based on its importance. Which factor is more important for me? Which factor is next more important? Like this, we have to decide. How to decide it? There are some steps involved in it. What are the steps? First step is list the most relevant factors in the location decision. For example, water supply, power supply, or labor, availability of labor, availability of raw materials. So which are the relevant factors in the location decision? It differs from each individual. Therefore, we have to decide for us which are the relevant factors. Then comes rate. Then we have to rate it. Each factor we should rate according to the relative importance, which is the highest, means most important factor, means we should give highest rating. And next to that we should give the ratings. Then comes rate each location, means location A, location B, location C. How many locations are there? We should rate each location according to its merits on each factor. We should locate it. And then comes compute. The product, means we should multiply. What is the ratings in the factor? What is the rating in the location? That should be multiplied. And the product multiplied amount, that is product, will be in another column. Compute the product of ratings by multiplying factor rating and location rating. These should be multiplied. Compute the sum of the product, means we should take the column total. For location A, what is the total of the product? And for location B, what is the total of the product? We should take the sum of the product. Then final is the decision. Decision, select the location alternative which has the maximum sum of the product. Ratings on the choice, which is the maximum point we should select, and that particular location will be selected. So this theoretical aspect can be understood more clearly with the help of an example. So in this example, there are factors like tax advantage and suitability of labor skill, Then comes the proximity of customers. How nearer you are to the customer. Proximity to suppliers means how nearer you are to the suppliers. Then comes the adequacy of water. Then receptivity of community. These are the factors. And these factors are given with the ratings like 4, 3, 3, 5. So which is the most important for the person, that is proximity of supplier, so he has given 5. Then comes the receptivity of community, so he has given 5 to it. Like this we have to decide, and we should give the factor. That is rating should be done. And next comes location rating, that is 8 to 6 it differs, and for location B also it is there. Now the task is take the product of these two. That means for location A, for example, here it is 8. As far as tax advantage is concerned, location A shows 8 and factor rating shows 4. These two should be multiplied. 8 into 4, that is 32. What, in which column you have to write it? Product of rating A. For that column, you should write the product. 8 into 4, 32. As far as location B is concerned, it is 6. So 6 should be multiplied by 4. 6 into 4, it is 24. It is written in the last column, that is product of rating B. In that column, we have written the 24. In the same way, think of the suitability of labor skill. Here, the factor rating is 3 and location rating for the A is 2. 3 into 2, that is 6 is written here in product rating A. And for location B, it is 3. Rating is 3. So if you multiply them, 3 into 3 is the 9 for product of rating B. In the same way, proximity of customers, 3, location A 5, that is 3 into 5, that is location A, it is 6. So 3 into 6, that is 18 for A, and 5 into 3, that is 15 for B. In the same way, proximity to supplier, 5, and for A, it is 2. So 5 into 2, that is 10, and 5 into 4 for B, that is 20. In the same way, we have to multiply and we have to take the product for A and also B for all the points. At the end, we should go with the total of it, and which is the highest one, that will be the best location for us. That is our decision. This is first method. And then comes the point rating method. That was factor rating method. Here it is point rating method. Here also we are doing the rating, but we are doing the rating for points, not the factors. In selecting site or location, companies have several objectives, but not all are of equal importance. Points are assigned for each factor. The site with highest total number of points is considered superior to the other sites. Here we are giving the ratings to the points. Again, let us watch one example and let us understand. See here, the factors are given, that is future availability of fuel. It is one factor. And according to the person who is going to do it, he says that maximum points he can give it for 300. As far as the availability of fuel is concerned, he says it is very important. So for me, it is 300 points. And transportation flexibility, it is also very important. So he says I can give 200 out of it. Out of 200, I will give the marks. Adequacy of water supply, 100. Labor availability is more important. So it is 250. Like this, maximum points are given, which is not so important. So I think pollution regulation, 30 is given. And site topography, 50 is given. So like this, maximum points is total, that is 1080. That is the maximum. And after this, we have to think of the assigned points to A, how in location A, what about the fuel availability? Okay, it is available. So out of 300, it is getting 200. And location B is getting 250. And as far as transportation flexibility is concerned, both are equal. So both have scored same. And adequacy of water supply, it is out of out. That means both A and B, they get the water supply. So we have given 100, 100. And labor availability, out of 250, location A gets 220 and location B is bit low, that is 200. And as far as pollution regularity, out of 30, both have scored 20. And here the site topography. So A is better, so we have given 40. And B is bit less, that is 30. Here in living conditions, out of 150, that is site A is getting 100 and location B is getting bit more, that is 125. Like this, we have assigned the score for location A and location B. Then we have to take the total of it. So how much score location A has earned? The total we have to take, that is 830. And how much score for location B? So we have taken the total, it is 875. Now you compare these two, which is better one, that is 830, 875. 875 is more than 830. Therefore, location B is comparatively better than location A. This is our decision. This is how we have made the solution of the problem. This is the point rating method. First one was factor rating method and this one is point rating method. And the third one is locational break-even analysis. That means we have to go with the cost. So it is called as an economic comparison of locations can be made by identifying the fixed cost and variable cost and plotting the break-even analysis on a graph for each location. That can be done. What are the steps for this method? First, you have to determine the relevant costs that vary with each location. Then, categorize the costs for each location into annual fixed cost, variable cost. That determination we have to make for each location. What is the fixed cost? What is the variable cost? And I hope you know it, Plot total cost associated with each location on a single chart of annual cost versus annual volume. Both has to be compared. What is the annual volume? What is the annual cost? Here cost means it includes both fixed and variable cost. Then select location with lowest total annual cost at expected production volume per annum. That is our job that we have to do. Here, let us go with the example here. Potential locations A, B, C are given. They have cost structures for producing a product to sell at rupees 100. What is this? That is the sales price per unit is 100. Find the most economical location for an expected volume of 2000 units. This is the expected volume, 2000. So our revenue will be 2000 units into rupees 100. Isn't it? For both the locations, this is the revenue. But what about the cost? Cost is given like this. A, B, C, 3 locations are there. And fixed cost, 25,000, 50,000, 80,000. And variable cost, 50 per unit, 25 per unit, 15 per unit. I hope you have understood what to do now. What happens here? 2000 units into variable cost we have to do. 2000 into 50, 2000 into 25, 2000 into 15. That will be the variable cost. And fixed cost is given, so we have to take that. Then we should add these two, then we will get the total cost. Let us see how it has to be done. To determine most economical location for an expected annual volume of production of 2000 units, calculate the total cost of production at each of the locations for the annual production volume 2000. How much it becomes? Let us see. Total cost means fixed cost plus variable cost per unit into quantity produced. So for A, what happens? See here for A, what is the fixed cost? That is 25,000. It is given in the problem, isn't it? Here it is given like 25,000. And variable cost is 50 rupees per unit. That is units is 2000. So for A, here what we are doing, fixed cost 25,000, variable cost 50 rupees into 2000. 2000 into 50 is 1 lakh plus 25,000 fixed cost. So total cost is 25,000 plus 1 lakh, that is 1,25,000. This is for A. In the same way, we should go with B also. Total cost is, that is how from where we have taken this 50,000. That is from the chart. See here, for location B, fixed cost is 50,000. Volume we have to take. So here we have taken the 50,000 and 25 rupees per unit into 2000. That is again 50,000. 50,000 plus 50,000. Total cost is 1 lakh for B. In the same way, we have to do for C also. So for C, what is the fixed cost? That is 80,000. What is the variable cost? That is 15 rupees per unit. So we have to, for C, we have to take the total cost as 80,000 fixed cost plus 15 into 2000. That is variable cost per unit into units. So 2000 into 15 is the 30,000 and plus 80,000 fixed cost. So the total cost is 1,10,000. By comparing the total cost at each location, see here for A, it is 1,25,000. For B, it is 1 lakh. And for C, it is 1,10,000. Which is the lowest? 1 lakh is the lowest. So out of 3 locations, B is most economical because it has got total cost very less. And along with this, one more question is there in the same problem. Determine range of annual volume of production. Here, what we are supposed to do, that is production, we have to take the break-even point, that is to determine range of annual volume. Determine break-even volume we have to go with. To determine break-even volume between location A and B, we have to consider the total cost equated. We should equate it. How we should equate? Take the total cost of A is equal to total cost for B. How we can do it? For total cost of A means for A, 25,000 is the fixed cost and 50 rupees per unit. So we don't know the quantity. So we are keeping it Q only. Is equal to, this is the fixed cost of B, that is 50,000. And per unit variable cost is 25. So it is 25Q. Now this is the equation, So we should solve the equation. So here 25Q has to be taken to this side of the equation. So now here it is 50Q, then minus 25Q. It is 20 plus 25Q. Here it becomes minus. And here 50,000 and we should take 25,000 to the other side. 50,000 minus 25,000. Now 50 minus 25 is 25Q. And 50,000 minus 25,000 is 25,000. So 25Q is equal to 25,000. Q is equal to 25,000 divided by 25. That is 1,000 units. This is the break-even point for A and location B. In the same way for B and C we have to do. For B, the same thing. That is 50,000 plus 25Q. And for C, fixed cost is 80,000. Variable cost is 15 per unit. So 15Q. Now again 25Q You bring this 15Q this side, 25Q minus 15Q, and 80,000 is here. You bring this 50,000 to this here, and 80,000 minus 50,000 is the 30,000. 25Q minus 15Q is 10Q. So 10Q is equal to 30,000. Q is equal to 30,000 divided by 10. That is 3,000 units. See, and for this break-even analysis, we got 1,000 units for A and B and 3,000 units for B and C. This is what asked in the problem. And I hope you have understood it. And the last method is qualitative factor analysis method. Here, it is a system of weighing the criteria. How to do it? The steps involved are: develop a list of relevant factors, then assign a weight to each factor to indicate the relative importance. Then what we have to do? Assign a common scale to each factor and determine minimum points to be scored. So what we have to do? We should develop a list of relevant factors now. What are the relevant factors? We should make a list. Then assign a weight. We should give weight to this. For each and every factor, we should give the weight. Then common scale should be assigned. And as a next step, score each potential location according to designated scale and multiply scores by weights to arrive at weighted score, and total points for each location, and choose the location with maximum points. That is how we have to do it. And this is the method of solving. Let us understand it with an example now. Otherwise, it will be not clear. Here, XYZ is a company. It is evaluating 4 locations. Which is better? It is comparing for a new plant and has weighted relevant scores as given below. Scores have been assigned with the higher values indicative of preferred conditions. Using these scores, develop a quantitative factor comparison for the 4 location. So it is given in the problem only, that is relevant factors. What are those? Production cost, then comes raw material supply, cost of living, environment, markets, then total. And assigned weight, this is also given, that is 0.35, 0.25, 0.20, 0.05, 0.10, and 1. And A, B, C, D, what are their scores? It is also given 50, 70, like this. It is also given. Now, what is our job? What should we do? These assigned weights should be multiplied with the factors in the A and with the B and also with C and also with D. Then what happens? See here, 50 into 0.35, that will be the score of A. And 40 into 0.35, that will be the score of B. And 60 into 0.35 will be for C. And 30 into 0.35 for D. This is for the production cost. Like this, we have to do for all the factors here. So this is what the multiplied thing, that is production cost 17.5, 14, 21, 10.5. And raw material again 17.5, 20, 20, 15. Like this, all the multiplication is being done and the value is being written here. So we should take the total for A, we should take the total for B and also C and also D. So see here, 60.5, 63.5, 66.5 and 49. Which is the highest score? Automatically it is 66.5. And which location has scored highest? That is location C. Therefore, location C is preferred because of the highest weighted score. I hope we have understood. And my dear friends, let us solve many problems especially break-even analysis and also this quantitative production, quantitative factors. So these methods are very important, and let us solve many more problems in the next videos. So I request you to give me the feedback for the improvement, and I hope you have enjoyed the solution of the examples and how we have arrived for it. So this was the thing today what we have discussed, and let me conclude the video here itself, and in the days to come let us go with more number of problems solutions in next videos. Thank you, Ananda.